Hi, this instructional video is about finding the sum of the geometric series. Finding the sum of the geometric series. Here's how it goes. First, let's determine what the common ratios are between each of the series of numbers. So to find that, the common ratio of r is equal to the next in line of the series divided by the initial, the first one. In this case, we got 30 over negative 90. Well, that just simply turns out to be negative 1/3. So that's the common ratio. That's the r. We also need to identify the first number of the series, a sub 1, which is in this case, sticks out as negative 90. Now to find out, if we were to add these numbers, what would the sum be? What would the total be if you went all the way up to the 16th term? So to find that, we use the general rule, S of the number, total number, whatever the series is equal to the first number, a sub 1, times 1 minus the common ratio r to the nth power over 1 minus the r. To find the total number of series added up together, what does it add up to? The sum? Well, we put the first number here, negative 90, times 1 minus the common ratio of negative 1/3 raised to the nth power. In this case, it's going to be 16. All over 1 minus the negative 1/3. So when we continue to evaluate the first number, negative 90, let's just leave it there for now. And we could use our calculator to determine 1 minus, check this out, even though it's a negative, since the exponent is is an even number, 16, we know it's going to be a positive number. So that's going to be 1 over. Now 3 to the 16th power, what may that be? So we go 3 raised to the 16th power. That gives me a huge number of 430,46721. All over 1 minus negative 1/3, that's like saying 3 over 3 plus 1 over 3, which is 4 over 3. And now since we have a coefficient of negative 90 and denominator 4/3, we could take that and evaluate. Negative 90 times the inverse, or the reciprocal of 4/3 is 3 over 4. That's going to become negative 270 over 4 times the numerator now. Now it says 1 minus this tiny little fraction of a number. And the common denominator is 430,46721. So this is like saying 430,46721 over 430,46721 minus the 1. So that's going to become 430,46720 over 430,46721. Now does the denominator 4 reduce 467,46720? Let's find out. So let's take that exponential number that we got and take out the 1 to make it into a numerator. And let's see if that's divisible by 4. Divided by 4. Yeah, it goes in evenly. So the 4 denominator reduces this big number on top by 107,61680. Over 430,46721. It doesn't look like the 270 is going to go into that denominator, so we'll leave it at that. And so we'll multiply negative 270 coefficient to the numerator of this fraction. That gives me a whopping huge number. We get negative 2905653,600 all over the denominator 430,46721. And let's make this into some sort of a real number, a decimal number, by going ahead and dividing it. That gives me approximately negative 67.495 or 67.5. So that means if we kept on adding all the way to the 16th term of these series, all that together add up to will become negative 67.5. So now the question is on part B, where on the series of these numbers will you find the sum of negative 66.67? And to find out, we're going to use the same finite geometric series. And we're going to say S of n is equal to a sub 1 times n 1 minus r to the nth power over 1 minus r. And we're going to fill in the numbers or information we have. First of all, the S of n is given as negative 66.67. The first of the series of this number, a sub 1, is given as negative 90. Times 1 minus r, the common ratio, we said it was negative 1/3. It is now we don't know what the n is. That's what we're trying to determine. So we leave it as an n. Over 1 minus the common ratio again, negative 1/3. And we're going to start evaluating. In this case, I'm going to get rid of the coefficient negative 90 by multiplying to both sides of the equation by negative 90. I mean 1 over 90. And what happens is, these two negative numbers will become a positive. Negative 66.67 over 90 is equal to, now we have here 1 minus negative 1/3 raised to the nth power over, well, we know what 1 minus negative 1/3 is. That's 4/3. And let's get rid of that quotient as well by, once again, multiplying to both sides of the equation by that denominator, which is 4/3. So on this side, this quotient cancels out the bottom, leaving you with just 1 minus, just 1 minus the quantity negative 1/3 to the nth power is equal to, now here, I don't want to really deal with what cancels with what, we'll just multiply across, so we get 3 times 90 is 270, over 4 times 66.67, let's see, 66.7 times 4, that gives me 266.8. Oh, wait a minute, no, well, that was close. That's 66.67, not 66.7, 66.67 times 4, that gives me 266.68. That's different. So that's going to be negative 266.68. Okay, and then I'll move the constant over to the left side, 1. Yeah, it's getting messy, isn't it? So the 1 on the right and its additive inverse cancels out, leaving me with just negative times the quantity negative 1/3 raised to an nth power. And on the left side, isn't negative 1, oh, I'm sorry, again, negative and negative here becomes positive. Okay, that's a positive. So now when I bring that negative 1 over, isn't that like saying 270 over 270? And 270 negative minus 266 gives me negative 3.32. So that's negative 3.32 over 270. And now, let's continue this on over here with the limited space that we do have. So let me go ahead and write this as positive because both sides are negative. So let's make this 3.32 over 270. But let's go and evaluate that into some sort of a real number instead of a quotient. 3.32 divided by 270. I get 0.012296, like that. So 0.012296. And that equals a negative 1/3. But since we're looking for a position, which term? The nth term. We don't care about the value. We're looking for a position. Like, is it first one, second one, third one, fifth one, whatever? So we don't really have to worry about the negative coefficient here. So we'll just go 1 divided by 3. And that's going to be 0.3333. 0.3333 raised to the nth power. Okay, now, we have an exponent. Could we not change the exponential form into a logarithmic form? Isn't this kind of like saying log base 0.3333 of 0.012296 is equal to n? Isn't that what that says? Same thing? Remember the log functions we talked about in the past? And then we use that thing called change of base formula. Can we just write that as n is equal to log of 0.012296 over log of 0.3333? Yeah, you're going to need a calculator for this. If you've been saving your money for a graphing calculator, scientific calculator, this is now you really need it. So we go, let's enclose this, each of the expression by saying parentheses, log 0.012296, close parentheses, divided by log 0.3333, close parentheses, and I get 4.0033. So the place value, which term, which end value, up to which point will you get a value of negative 66.67? It will be up to the fourth. See? So that'll be the answer. Wow! Now that you saw that, it is up to you to try to figure out this one. Okay? Here are the series of numbers from given geometric sequence. 1, 4, 16, and 64. Okay? What would the sum be if you added all the series all the way up to the 14th term? And where in this series, if you added the sum, will you get 341? Try it. Okay, so you said, first thing I should do is find the common ratio. And the common ratio is determined by R is equal to the next term in the series divided by the first term. In this case, it's 4 over 1. Or simply 4. They're in factors of 4. 1 times 4 is 4. 4 times 4 is 16. 16 times 4 is 64. So on and so forth. And what is the initial number on this series? It's quite simple. It is, in fact, 1. Yeah, I give you the easier one. You're welcome. So now you're going to find the sum all the way up to the 14th term and try to determine what you'll get. The number will still come out crazy. We got S of n is equal to a sub 1 times 1 minus the common ratio n raised to the nth power over 1 minus r. Okay, memorize that. Okay, here. That's a brain. Memorize that. Or it's a cloud. Okay, so now you say, okay, then what is the 14th? If I add it up to the 14th, what would I get? That's how you indicate it. And the initial number is 1. That was no biggie. 1 minus the common ratio r is 4 raised to the nth power. And nth is again the 14th term. Over 1 over the 4 common ratio. And we start evaluating like crazy. So it's an identity 1, so we don't have to worry about that. So we got 1 minus 4 raised to 14th power. What is that? 4 raised to the 14th power. I get a huge number again of 2684,35456. 2684,35456. All over 1 minus 3. 1 minus 4, which is negative 3. Then I'm going to take away 1 from this negative big number, so I get negative 2684,35455 divided by negative 3. And negative becomes positive. Let's hope that this comes out to be something of a nice number. So let me take away 1 from what I had before. Okay, now divide that by 3. Nice. I get some sort of a huge integer. Okay, so I get 89478485. What is that? That is 89,478,485. That's the value, that's the sum that I will get if I add it up all the way to the 14th term. That is growing quite huge like. Now the second question is, where in this series, which term will you find the sum 341? Okay, well it's not going to be the 14th term because that's going to give you a huge millions numbers. It's going to be somewhere in the closer of a single digit number. Okay, alright, so that being the hint, let's go ahead and write this again. The general rule is S of n is equal to a sub 1 times 1 minus r to the nth power over 1 minus dr. Now we know we are given the value of the unknown term, that's 341, so we put that there. Initial number a sub 1 is 1, right there. Now the inside, 1 minus the common ratio r, we said it was going to be a 4. And this time we don't know what the n is. That's what we're trying to find. Over 1 minus the common ratio of r again, 4. So we're going to start evaluating. So in this case, we get 341 is equal to, well, that's an identity. We don't have to worry about that. So here we have 1 minus 4n, and on the bottom we have negative 3. So let's get rid of that denominator negative 3 by multiplying it to both sides of the equation. So here it simplifies out. So all we're going to have is 1 minus 4 to the n power. On the left, it's 3 times 341. So 3 times 341. It says 1023, and it's a negative, of course. Negative 1023. Now let's bring that 1 over constant by subtracting both sides. So additive inverse 1 and the minus 1 cancels. And on the left, again, it becomes a bigger negative of 1024 is equal to negative 4 to the nth power. And since they share both a negative coefficient, we could just cancel them out and say, well, that's like saying 1024 is equal to 4n. Now we're going to go back to our log functions. Isn't that kind of like saying, coming back over here, isn't that kind of like saying log base of 4 of 1024 is equal to n? Isn't that what that means? Yeah, 4 raised to one number where you get 1024. And that's how we convert it into a logarithmic function. So in this case, change of base formula says we could write this as n is equal to log of 1024 over log of 4. And no, you cannot simplify the base, the y values 1024 and y. No, that's not the way it works. You wish. But instead, you have to go close parentheses, or open parentheses, log 1024, close parentheses, divided by log 4 equals, nice, 5. So where will you find the sum up to which term will you have to add so that when you add them all together, you will get a 341? Up to 5. Check this out. Here's 1. Plus 4 is 5. Plus 16 is 21. Plus 21 plus 64 is 85. And 85 plus, what's next after that? 64 times 4 is 128? Well, no. 156? Okay, so 85 plus 156 is 341. Okay? There it is. So that is the right answer. Yay! Alright, now go get them.